used is shown below.
Alpha amylases are hydrolytic enzymes that are widespread in nature, being found in animals, microorganisms, and plants. Amylases are among the most important enzymes in present-day biotechnology. The enzyme has found numerous applications in commercial processes, including thinning and liquefaction of starch in alcohol, brewing and sugar industries. Alpha amylases are extracellular endoenzymes that randomly cleave alpha-1, 4 linkages between adjacent glucose units in the linear amylase chain and ultimately generate glucose, maltose, and maltotriose units, conversion of starch into sugar syrups like glucose maltose, maltotriose. Dextrins, sugar, or fructose syrups are the major part of the starch processing industry. Alpha amylases have been isolated from different sources. This class of industrial enzymes constitutes approximately 25% of the enzyme market. Application for purification of amylase alike in brewing, pharmaceuticals, textile, and preparation for digestive aids. Materials and method are divided into 4 steps. Step 1. Enzyme production and preparation of self-refiltrate. Aspergillus flavus vacularis was grown under the entire of optimized parameters using solid-state fermentation conditions as previously mentioned by L. Safian 2002. The filtrate broth was collected and centrifuged at 4,000 revolutions per minute for 15-minute forcing and then filtered through a sterile sintered glass G4 in order to obtain a self-refiltrate. After performing a test for sterility, 200 ml of the CFF containing alpha amylase were collected and the amylolytic activity and protein content were determined. 200 milliliters of the crude alpha amylase enzyme were first brought to 20% saturation with solid ammonium sulfate. Is mentioned by Dixon in Webb 1964. The precipitated proteins were regimented by centrifugation for 15-minute 500 revolutions per minute. The resulted pellet was dissolved in 5 milliliters of 0.2 m phosphate buffer at pH 6.2. The left supernatant was applied again with ammonium sulfate to achieve 40, 60, 80, and 100% saturation. Both enzyme activity and protein content were determined for each separate fraction. The clear supernatant was passed through a column of CM cellulose. The column was eluted with 500 milliliters of the equilibration buffer followed by elution with a linear gradient. Formed between 100 milliliters of 0.02 mu acetate buffer pH 5.0 and 100 milliliters of the buffer containing 0.2 m sodium chloride. The solution was concentrated to ultrafiltration and dialyzed against 40 volumes of 0.02 mu HCl buffer pH 9.0 for 24 hours. Figure 1 shows the chromatography of the ammonium sulfate fraction on CM cellulose column. Step 3. Dialysis against distilled water and buffer. The obtained ammonium sulfate precipitate in solution was introduced into a dialysis bag against distilled water for 3 hours, followed by dialysis against phosphate buffer at pH 6.2. The obtained alpha amylase enzyme preparation was concentrated against crystals of sucrose and kept in the refrigerator at 5°C for further purification. Step 4. Application on column chromatographic technique. Preparation of the gel column and the fractionation procedures was determined as previously mentioned by MR 1975. For this purpose, a pharmacia column has been used. Cefadex G200 was also used. 0.2 M phosphate buffer of pH 6.2 was used, and the slurry was allowed to swell for 3 days at room temperature. Sodium azide was added to prevent any microbial growth. Applying a mixture of blue dextran 2000 and bromophenol blue determined the void volume. 1 ml of the enzyme preparation sample was applied carefully to the top of the gel and allowed to pass into the gel by running the column. Buffer was added without disturbing the gel surface into the reservoir. 50 fractions were collected. Amylotic activity and protein content were carried out for each individual fraction. Sharp peaks of fractions obtained after applying Cefadex G200 column were collected and investigated for the properties of the partially purified alpha amylase enzyme. Fractionation using ammonium sulfate in ratio of 0 to 40, 40 to 70 and 70 to 90%. The fraction were separately dissolved in minimum amount of 0.1 M acetate buffer with pH 5. Then dissolved in 0.1 M acetate buffer, dialyzed overnight again with the same buffer. Assay is done to determine total soluble proteins and enzyme activity. A picture example of the molecular weight of purified enzyme was determined by SDS page using BSA, a standard enzyme and BSA. The molecular weight of purified enzyme was 65 8-day approximately. This is the summary between ammonium sulfate fractionation and partial purification. The techniques used during the extraction and purification. Ion exchange chromatography separates compounds based on net surface charge. Molecules they are classified as either anions or cations. Some molecules, as example protein, may have both an anionic and cationic group. Gel filtration is also known as size exclusion chromatography. It separates molecules based on differences in size and a molecular weight. Ultrafiltration is a technique for separating dissolved molecules in solution on the basis of size. Molecules which are larger than the membrane pore size will be retained at the surface of the membrane, while water in low molecular weight solutes will pass through the membrane. Is for conclusion, the purification methods that was described in the first journal as ammonium sulfate precipitation method and Cefadex G200 chromatography. The precipitate of crude enzyme was dissolved in a minimum volume of 0.2 M phosphate buffer pH 6.0 and dialyzed overnight in a dialysis bag against the same phosphate buffer at pH 6.2 at 4 degrees Celsius. Ammonium sulfate precipitation resulted in specific activity of 3,670.51 units, mg/prot, ml, both of. The amylase was produced by using solid-state fermentation with usage of Aspergillus oryziendi. Another one with Aspergillus falvus var columnaris. Cefadex method uses ammonium sulfate to prepare crude enzyme. Partial purification method uses filtration to prepare crude enzyme extract.